So today we're going to talk about how you use your unit circle to solve trig questions. And this is trigonometric functions of real numbers. You're going to notice in what we do with what remaining time we have left with trig functions, we're going to be dealing with radians and not degrees. So that's the real numbers part. First of all, just as kind of a little review from that video, and I did have you watch that video because I wanted you guys to have a chance to see how the unit circle is built, because that really is important and we didn't have a chance to do that. But these ordered pairs, the first coordinate represents the cosine of the angle and the second coordinate represents the sine of the angle. So if you wanted to know sine of 5 pi over 6, remember all of these angles are measured from standard position, which means the initial side is on the positive x-axis, and then this would be the terminal side since it's 5 pi over 6. So we're talking about this angle right here. So here's the 5 pi over 6. Sine is the y coordinate, the y value, so our answer would be 1/2. Cosine of 5 pi over 4, you're going to locate the 5 pi over 4, which is here. Cosine is the x coordinate, so we get negative root 2 over 2. And tangent of 5 pi over 3, you'll notice there is no tangent listed on there. Just as kind of a little reminder, let me show you how these are related. So if this is theta, and this is x, and this is y, and this has a value of 1 because it's the unit circle. So remember the radius is 1 on the unit circle. So I'm taking a little section of my circle out. So if you were to do, for example, sine theta, you would do opposite over hypotenuse, which was y over 1, or just y. So we get y equals sine theta, thus the y coordinate. And if we do cosine of theta, we get adjacent, which is x over 1, or we could say x equals cosine theta, thus the x coordinate. But what about tangent? Well, notice that tangent is opposite over adjacent. So it would be y over x. But remember, we just said y is sine theta, and we just said x is cosine theta. So we just proved something that's actually called an identity. An identity is an equation that is always true for all values of theta. So we just proved this identity. And that's what we're going to do to find tangent. So if we want to know tangent of 5 pi over 3, we have to first figure out sine of 5 pi over 3 and put that over cosine of 5 pi over 3, because you're going to do sine over cosine. So then you look over here and you find 5 pi over 3, which is here, and you're going to put the sine value on the top, so negative square root of 3 over 2 divided by 1/2. Remember, when you divide by a fraction, kind of running out of room here, you change it to multiplying by the reciprocal. So dividing by 1/2 is the same as multiplying by 2 over 1. The 2's will cancel, and you get negative root 3. You kind of put a little dividing line there. And this would be your answer for tangent 5 pi over 3. Now here's a shortcut a lot of you will want to do. Because when the denominators are the same, when you have a fraction divided by a fraction, you can do this. That's a shortcut instead of flipping it over. And so that will work if you want to take that as a shortcut when you're evaluating tangent. Now, something else I want you to notice from the unit circle is if, say, you have a 6 on the bottom, say your angle. So pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Notice that all the cosine values are either plus or minus root 3 over 2, and all the sine values are 1/2. Okay, so there's that in common. So if you remember pi over 6, then you should be able to figure out easily 5 pi over 6, 7 pi over 6, 11 pi over 6, what the sine and cosine are. Similarly, the pi over 4s, actually pi over 4s are even easier. Anything that it has a 4 on the bottom, the sine and cosine are both square root of 2 over 2. If it has a 3 on the bottom, then the sine and cosine are flipped around from what they were for pi over 6. So pi over 3, cosine is 1/2, and sine is root 3 over 2. So notice everything with a 3 on the bottom is the same. So if you just know these 3 right here, then you can actually figure out any of these really easily by just knowing the quadrant of the angle. And we've actually kind of done this. We just didn't have a unit circle. All right, this is a chart that is on page 519 in your textbook. And these are called quadrantal angles. Switch back to blue here. It's easier to see, I think. These right here are called quadrantal angles because they are the ones that are on the quadrants. So, for example, if you have your unit circle, so this point right here would be, remember this is 0, 0. So you go over 1. A unit circle has a radius of 1. So this would be 1, 0. This would be 0, 1. This would be negative 1, 0. And this would be 0, negative 1. So the idea of the x-coordinate being cosine and the y-coordinate being sine, it still holds true. So sine of 0 is 0 because it's the y-coordinate. Cosine of 0 is 1 because it's the x-coordinate. For pi over 2 is up here at the top. So the x-coordinate is 0, so that's cosine. The y-coordinate is 1, so that's sine. For the value of pi, so pi would be here. So the coordinates are negative 1, 0, and I'm not going over that again. If you watched the video on the unit circle being built, then you know that. So the x-coordinate's negative 1, so cosine of pi is negative 1. And the y-coordinate is 0, so sine of pi is 0. And 3 pi over 2 is down here at the bottom. The x-coordinate is 0, so that's cosine. And the y-coordinate is negative 1, so sine of 3 pi over 2 is negative 1. Now, to get tangent, remember we put sine over cosine. So you're going to divide 0 divided by 1, which is 0. But then for tangent of pi over 2, you would have 1 over 0, which is undefined. For tangent of pi, you put 0 over negative 1, it's 0. But notice here, negative 1 over 0 is undefined. For cosecant, you flip over sine. Well, if you can't flip over 0. This is like having 0 over 1, and if you flipped it over, it'd be 1 over 0. So that's why it's undefined. But you can flip over a 1, it's still 1. Flipping over a 0 is undefined. And because remember, cosecant t is 1 over sine t. Remember that. That's also an identity. It's called a reciprocal identity. And cosecant of 3 pi over 2 is going to be negative 1. Secant. So secant t is equal to 1 over cosine t. That's the reciprocal for that one. So if you flip over a 1, you get a 1. Flip over a 0, it's undefined. Here it's a negative 1. Here it's undefined. And cotangent, we're going to flip over tangent. So here would be, or actually we could think of cotangent t as cosine t over sine t. Think about that because tangent, cotangent, tangent flipped over. So I'm just flipping over what we said was equivalent to tangent. So here we're going to have, well, if tangent is 0, then cotangent's undefined. If tangent's undefined, then cotangent is 1, because we would have had 0 over 1. And here it's also, this one's going to be negative 1, because we're going to have 0, oh, wait. Okay, I don't want to redo this, so I'm just going to pretend like I can rewind. Flipping this over, we're going to have, for cotangent, we're going to have 0 over 1, which is 0. And here, same thing, 0 over negative 1, which is 0. Okay, so now I got it right. So this would be the quadrantal angles. And again, just using this, you know, those are important. So you definitely need to know those. All right, so using that unit circle. This is how I do it because I don't ever look at a unit circle, but you can. That's okay. Those of you who are taking AP Calculus, this is one of the things you have to have memorized. You have to be able to find these trig values. You cannot use a unit circle, so just be aware of that. Now, what I remember is I know that sine of pi over 6 is a half. I just memorized that. One thing. Memorize one thing. If you can memorize that. So that means I know this has to be a half. It might be positive, it might be negative. But it has to be a half because it has a 6 on the bottom. And that's all I have to look at. So 7 pi over 6 is a little bit bigger than pi. Okay, because think about it. 6 pi over 6 is pi. So this is a little bit bigger than pi, which makes it quadrant 3. Okay? So if it's in quadrant 3, all students take calculus, so sine is negative, so I get negative a half. That is my thought process. That is what I do. You can look at the unit circle, but again, those of you going on to calculus, you won't have that to use. Okay, how I do this one. Cosine of pi over 6, and why do I want to know that? Because there's a 6 on the bottom, is root 3 over 2. And how do I know that? Well, because I just said sine pi over 6 was a half, and that's always, these always go together. So if sine is the half, then cosine is root 3 over 2 on that one. So remember, this is the one I memorized, the sine, and then I just know this is the other one. So I know my answer has to involve the square root of 3 over 2. Now I need to know the quadrant. Well, I'm going to subtract 2 pi, and since I'm in 6, that's going to be 12 pi over 6. That would be 2 pi. And I get 5 pi over 6. That would be a coterminal angle. So I already determined 5 pi over 6. Oh, no, that was 7 pi over 6. So 5 pi over 6 is a little bit less than pi, because 6 pi over 6 would be pi. So that makes this quadrant 2. And all students take calculus, so cosine is negative. So we get negative root 3 over 2. Tangent 7 pi over 6. Okay, well, for that one, I'm going to take sine of 7 pi over 6 over cosine of 7 pi over 6. Okay, sine 7 pi over 6 we already said was negative a half. So I know cosine, it's quadrant 3, and that was going to be negative. So negative, if this was a half when there was a 6 on the bottom, then this is root 3 over 2. The 2's will cancel, and it's going to be a positive. I get 1 over root 3. And if you wanted to rationalize that, it would be root 3 over 3. So that's how you do that. Okay, now I know you might look at it and say, but it would be a whole lot easier just to look at my unit circle. And honestly, those of you who are in a non-calculus path, go for it. But those of you who are headed towards calculus, you should listen to my strategies and try and do that. Okay, next one. Sine is 7 pi over 3. There's a 3 on the bottom. Well, I know sine of pi over 6 is a half. That means sine of pi over 3 is the other one, root 3 over 2, because those always go together. So again, this is what I memorize. This is my thought process. So I know this has to involve a root 3 over 2. It could be positive, it could be negative. Now I have to think about the quadrant. Well, notice that there's a 3 on the bottom, and if I subtract out 2 pi, I get pi over 3. Okay, so this is a coterminal angle. So that means this is quadrant 1, and it's positive. So that's my answer. Cosecant 7 pi over 3. Well, cosecant 7 pi over 3 is 1 over sine 7 pi over 3. So it is just the reciprocal of what we just did. So it's 2 over root 3. So if I'm all right with you leaving that, but if I rationalize it, I get 2 root 3 over 3. And it's going to be positive because sine was positive, so they both will be. And then cotangent 7 pi over 3, I'm going to take, now it's cotangent this time, so I'm going to say cosine of 7 pi over 3 over sine of 7 pi over 3. So I already know this one, we already did it, root 3 over 2, and we already determined it was quadrant 1. So if this is root 3 over 2, this is the other one, so it has to be a half. And the 2's cancel. I get 1 over root 3, which rationalizes to root 3 over 3. Also, for those of you going on to calculus, like taking the AP exam, if you are going to do that, 1 over root 3, that's fine. You can actually, you don't have to rationalize the denominator, but sometimes you see it rationalized, so it's good to know. So hopefully that helps with that. Now I noticed that I didn't do one with a 4 on the bottom, like something pi over 4. Those are actually even easier because then it feels like everything is root 2 over 2. Well, sine and cosine are. So, you might have one like that. All right, I'm doing another problem. I'm doing problems that are similar to all your homeworks. So problem 33 says the terminal point in P with coordinates x, y determined by a real number t is given. Find sine t, cosine t, and tangent t. So basically what they're saying is we have some terminal point that's on the terminal side, because remember, positive x-axis, the terminal side is somewhere in quadrant 3. So don't worry, you don't have to plot it. I'm just doing this so you can kind of see what's happening. So negative 5/13, negative 12/13, so it's somewhere down here. And so this is basically your angle that you're looking at. And we're trying to find sine t, cosine t, and tangent t. And this is built on a unit circle if we drew one out. So sine t is the y-coordinate, negative 12/13. Cosine t is the x-coordinate, just like on the unit circle. Tangent t, we're going to put our sine value over our cosine value. The 13s cancel, and it becomes a positive 12/5. And that's all there is to it. So that one, the instructions make it sound so hard, but it's not. Number 45 on page 519, find the sign of the expression if the terminal point determined by t is in the given quadrant. So if we have a quadrant 2 angle is really what that's saying. And this is times. So I want to know what would sine t, what's the sine of sine t times cosine t if the angle t is in quadrant 2? Well, quadrant 2, we know sine is positive because remember we have all students take calculus. So this tells us where it is positive. So sine is positive. Cosine is, in quadrant 2, cosine is negative. So my product is negative. We've done some similar to that before, but not with these kind of confusing sounding directions. And number 49 on the same page, find the quadrant in which the terminal point determined by t lies. Okay, so if sine t is positive, then all students take calculus, so this could be quadrant 1 or 2. Cosine is negative, so this could be quadrant 2, because cosine is positive in quadrants 1 and 4, so this could be 2 or 3. So what's common to both? So this must be a quadrant 2 angle. Again, I think we did something like that. Okay, so this one, find the values of the trigonometric functions of t from the given information. So we're told sine t equals negative 4/5, and we're told the terminal point of t is in quadrant 4. Once you know it's in quadrant 4, so I know the angle, basically that's telling me it's a quadrant 4 angle. And I'm trying to find the values of the other trig functions. I know sine. So you're just going to build, a triangle, a right triangle for this one. And it's the generic triangle. I guess we should call it a T this time instead of a theta because that's what it's called here. Remember, sine is opposite over hypotenuse. When you solve for the other side, this triangle is clearly not solved to scale because when you do 5 square minus 4 square, you'll get 9, and so this is 3. And then you're going to determine all the other trig functions. So we need cosine t, tangent t. I'll just put in sine also. And then we'll have cosecant t, secant t, and cotangent t. That looks funny. So this is negative 4/5. Since it's quadrant 4, then cosine is also, cosine is positive. Tangent is negative. cosecant, and cotangent negative. So this is just going to be 5/4, negative 5/4. Cosine, adjacent over hypotenuse, is 3/5. Secant would be 5/3. Tangent is going to be opposite over adjacent, so negative 4/3, so this would be negative 3/4. Don't forget the t when you do that. Don't just say sine equals or cosine equals. You have to have the angle in there as well. And on this one, number 67, find the values of the trig functions of t from the given information. So now I'm told that sine is positive and tangent is negative. So if sine is positive and tangent is negative, that tells me that t is in quadrant 2. Can't be quadrant 1, which sine is also positive, because then tangent would have been positive as well. Once you've determined that, and then you just draw a generic triangle, my angle's t. So we have 12 and 5. Again, not drawing the scale. My triangles all look the same. So then we have, this is going to be 13. You can do the math, but 5, 12, 13 is a Pythagorean triple. So that's what that is called. So then we have sine t, cosine t, tangent t, and cosecant t, secant t, cotangent t, and this was negative 12/5, so this is negative 5/12. And if we are in quadrant 2, then cosine is negative and secant is negative. Sine would be 12/13, so this is 13/12. Cosine would be 5/13, it's negative, so this would be negative 13/5. Okay, so again, we've done some like that before. I think that is it. Yes, so this should help you get through your assignment. Since the video is more than 20 minutes, I will hold off and do the assignment the following day. So tomorrow you just have to upload your notes for this assignment.